All right, so in this video, I've added some variables and we're gonna go through and we're gonna do our factor trees and break these down very similar to how we did the numbers. So let's go ahead and jump right in. We want to break down the square root of 4x to the third. So we want to simplify the square root of 4x to the third. If you do not see an index on the outside, so that's our little number on the outside. If you don't see a number on the outside, my understood index is the number 2. So we need to write that out there, nothing wrong with that. We'll go through, we'll do our factor tree. That's 2 times 2. Now, the exponent tells you how many times to write the variable. So x. It said x to the third, so x. I'm looking for pairs because my index is 2. I'm looking for pairs, so groups of 2. So I have a pair here, and I got a pair here. Complete groups of your index go on the outside of your square root. So complete groups of the index go on the outside. I got a complete group here. I got a complete group here. Everything else goes on the inside. I don't have any leftover prime numbers, so there's no number left over, but I do have a leftover x. So this is our final answer. 2x times the square root of x. So 2x times the square root of x. Complete groups go on the outside, leftovers go on the inside. So that's my answer. And I can shorten this a little bit. It was kind of long there. There we go. So that's my final answer. Let's move on and we'll do B. So final answer here. All right. B, same thing. If I don't see a number on the outside, my understood index is the number 2. You do not have to write it, but if it helps you remember, okay, I'm looking for pairs. I'm looking for 2 of the same number or 2 of the same variable. So this is 12x squared y to the 5th. 12x squared y to the 5th. So let's do a factor tree. 6 times 2, 3 times 2. I have 2 x's, and I got 5 y's. 1, 2, 3, 4, 5. I'm looking for groups of 2, looking for pairs. So I got a pair of 2's here. I got a pair of 2's here. I have a pair of y's, and I have another pair of y's. Complete groups go on the outside. So what you've circled goes on the outside. So complete groups. I got a complete group here, so that's 2. I have 1 x group, and I have 2 y groups. So that's y times y. Leftover prime numbers go on the inside. So my leftover prime number is the number 3, so that's left over. I don't have any x's left over, and I have 1 y that is left over. So your final answer, you would just multiply anything that needs to be multiplied. So my final answer is 2xy squared times the square root of 3y. So final answer, 2xy squared times the square root of 3y. So complete groups go on the outside. Everything else goes on the inside. Okay. After one more example, I will just show you a shortcut to do with your variables so you don't have to write those out. But since we're just getting started, I am going to write those out so we can go through and circle what we need. But in a couple of minutes, I will go through and do some shortcuts for us. All right, C, I need to break down 125. So 125, I know that can be multiplied as 25 times 5. So I'm going to start my factor tree off with 25 and 5. I'm going to break down 25 into 5 and 5. I got 4 K's. 1, 2, 3, 4. I got 3 M's. 1, 2, 3. And I got 1 N. So the variable tells you how many times that you can list out your variable. My index on the outside is the number 2. So I'm not going to write that this time. It's understood to be there, but I'm looking for pairs. I'm looking for 2 of the same number or variable. So I got 2 5's, 2 K's, 2 K's, 2 M's, and that's it. So those are all my pairs that I have. So complete groups of your index go on the outside of your radical symbol. So I have a 5 that goes on the outside. I have 2 groups of K, so that's going to be K squared because I got two groups of K. I got one group of M, and those are all of my pairs that I have. So that's it. Everything else is going to go on the inside. Leftover prime numbers, I got a 5. I have no K's left over. I have one M left over, and I got one N left over. So this is my final answer. So 5K squared M times the square root of 5MN. So 5K squared M times the square root of 5MN is my final answer. Pairs go on the outside. Everything else goes on the inside. Unless you change the index, which we are about to do now. So for D, my index is 3. So this time I'm looking for 3 of the same number or 3 of the same variable. So I'm going to break down 54. That's 9 times 6. This is 3 times 3. This is 3 times 2. 1, 2, 3, 4. Because it's x to the 4th. So we're finding the cube root of 54x to the 4th. I'm looking for 3 of the same numbers or variables. So my index this time is 3. So I have a group of 3's here, and I have a group of 3's there. Complete groups of your index go on the outside of your square root. Everything else goes on the inside. So I have a complete group here of 3, and I got a complete group here of x. Now I'm going to bring my index down this time. So I got an index. Leftover prime numbers go on the inside. My leftover prime number is the number 2. And my leftover variable is x. So this is our final answer. 3x times the cube root of 2x. So 3x times the cube root of 2x is my final answer. All right, let me talk about a shortcut real fast before we do the last 2 problems with your variables. A shortcut that you could do instead of listing your variables out is just to divide. So if I go back to the first one, this is a 2, and that's a 3. 2 goes into 3 once, which is why I had one group of x on the outside. So this is going to help us with our variables. So 2 goes into 3 once. So I had one complete group on the outside, and I have a remainder of 1. So the same thing that I did here. I got a complete group, remainder of 1. Let's take a look down here at B. Okay, 2 is my number. 2 goes into 2 once. So I only have one x on the outside. 2 goes into 5 twice because 2 times 2 is 4. So notice I had 2 y's on the outside. And then you have a remainder of 1. So 1 y goes on the inside. So a shortcut that you can do is divide. Let me explain that again with C and D, and then we'll see if we can use that with E and F. So again, my index is 2. 2 goes into 4 twice. So I have 2 k's that were on the outside. 2 goes into 3 once. So I have 1 M that was on the outside. Your remainder goes on the inside. So 2 goes into 4 twice. There's no remainder, no K's. 2 goes into 3 once, and you have 1 remainder. And 2 does not go into 1, so that's why the N came down. And the same thing here, if I take a look at D, 3 goes into 4 once, so I have 1 complete group, and then I got a leftover here. So a shortcut that you can do instead of listing out your variables, particularly if the numbers get big, you can just take your index and divide it into your exponent. All right, last 2 problems. We're going to break down 216 and break down 48. 216, let's do 6 and 36. This is going to be 2 times 3. This is going to be 6 times 6, 2 times 3, and 2 times 3. So I did a factor tree. I broke it all the way down. I did a factor tree. So same thing we've been doing for a while here. I'm looking for pairs. So I'm looking for, no, I'm not. My index is 3. So I'm looking for 3 of the same numbers. So make sure we double check our index there. I'm looking for 3 of the same numbers or variables. So let's check it out. I got some 2's that go together. So I'm going to try to circle those to the best of my ability. All right, so that's my group of 2's that I circled. 1, 2, 3. And I'm going to do my threes in a different color so I don't get those confused. So 1, 2, 3. So I'm looking for 3. I'm looking for groups of 3. I have 1, 2, 3. I got a group of 2. And then 1, 2, 3. I got a group of 3. Complete groups go on the outside. So on the outside, I got a complete group of 2. And I got a complete group of 3. So that's going to go on the outside of my square root. Let's use our shortcut for the variables. 3 goes into 3 once. So on the outside, I'm going to have 1x. 3 goes into 5 once. So on the outside, I'm going to have 1y. We're going to write our index, which is 3. Leftovers go on the inside. So leftovers are going to go on the inside. I don't have any leftover prime numbers, so check there. I don't have any leftover x's because they were all used. 3 goes into 5 once, but I have 2 left over. So 2 goes on the inside. How do I know I have 2 left over? Because 3 goes into 5 once to get to the number 3, and then 4 or 5. You have a remainder of 2, so I'm just dividing. So my final answer is 6xy times the cube root of y squared. That is our final answer. 6xy times the cube root of y squared. And the last one, we're going to break down 48. Lots of things gives me 48. I'm going to do 8 and 6. 4 times 2, 2 times 2, 3 times 2, and I believe that's it. Let's check and see what our index is. And index, I don't believe I've written it out, but this is what I'm saying here. Index is the number on the outside, so that's called your index. So let's check what my index is. It's the number 4. So I'm looking for 4 of the same number. So, boom. Okay. So I have a group of 4. I have 4 2s, group of 4. So that 2 is going to go on the outside. Complete groups go on the outside of your square root. Now let's use the shortcut. 4 goes into 10 twice because 4 times 2 is 8. So 4 goes into 10 twice. 4 goes into 5 once because 4 times 1 is 4. Write your index down. Leftovers go on the inside. So if I look over here, I have 1 leftover prime number, and that number is 3. 4 goes into 10 twice. 4 times 2 is 8, and we have a remainder of 2. So 2x squared goes on the inside. 4 goes into 5 once, and I have a remainder of 1. So this is our final answer. 2x squared y times the 4th root of 3x squared y. So 2x squared y times the 4th root of 3x squared y. So I did use the shortcut with E and F. If you need to list out the variables and circle them like we did with the first 4 problems, there's nothing wrong with that. Feel free to do what you need to do to be successful and to get the correct answer. So in summarization, check your index that tells you how many, that tells you what groups you should have. Groups of 4, groups of 3, groups of 2, etc. Complete groups of your index go on the outside. Everything else goes on the inside of your square root.